Hey everybody, this is Larry. This is day 16 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. Range sum query immutable. Oh yeah, Oh, what I was going to say is that, I always try to urge people in general to take victories small and big. I finished 39 from the recent Leetcode contest, so I feel good about it, even though I made a mistake that knocked me out of the top 25. But it was fun. It's been a while since I did okay, so mostly because I was traveling. But so I don't know. Anyway, okay, let's back to range sum query immutable. Given a sum, multiple calculate the sum between left and right, inclusive. Implement blah blah blah. Inclusive. Okay. So the thing that I was looking for is whether I guess if they tell you it's mutable, but I wasn't sure exactly what that means. But this is actually a good prefix sum problem because it is immutable because you don't have to change anything, right? And you can change. That's when there are fun data structures that you can look into, like the Fenwick tree or the binary index tree or just segment tree, or there are a lot of things you can do, but that's the first thing that I looked for. And because this is immutable, you can actually just pre-process the array to kind of enter every possible query. And the way that I always explain it, and this is a good prefix sum problem per se, or I don't know if it's a good prefix sum problem, but it is as prefix sum as you can get. But the idea behind prefix sum is that, okay, so you have sum of ij is equal to, well, another way, and sum of ij is equal to, say, what is this? Okay, let's say a sub I plus a sub I plus 1. Let's pretend there's subtitle. This is annoying to write, so let's pretend that's the case. I plus 2 plus dot a sub j, right? So the quick answer here is that this is basically what you're trying to do here. And if you do a for loop, it's going to take too long, or otherwise it's not an interesting problem. I mean, it's still maybe not super interesting. But the thing to notice is that, okay, you can rewrite this as zeros. Well, what's this thing, right? So this thing is equal to a sub 0 plus a sub 1 plus a sub 2 plus dot all the way plus a sub I minus 1. And sum of O to j is just equal to the same thing, which I'm going to copy and paste a little bit, all the way to j. But, okay, maybe we'll take this. Plus a sub I, a sub I plus a sub I plus 1 plus dot plus all the way to j, right? So the idea here is that if you have all these numbers from 0, you could subtract this from, you can subtract line 6 from here, line 7, and what do you get? And you get something like this. Equals, and you can see that the a sub 0 cancel out, a sub 1 cancel out, a sub 2 cancel out, dot, all the way up to here, and all you have left is this thing, right? And all you have left is this thing, and which is what you are looking for. So another way of saying this is, of course, I sub j is equal to sum of oj minus sum of oi minus 1. Okay, so now that means that all we have to do is pre-process this, and there are a couple of ways of doing it. I usually do it this way in Python, but I don't, it doesn't really matter. Find a way that is familiar to you, so that you can kind of, so that you are just consistent all the time. And this is the way that I write it, but I don't know. It's a little bit yucky, maybe even, but yeah. And okay, just want to make sure that the left and right and thing. But the key thing to note, of course, is that I'm actually off by 1 here in my formulation here, because let's say you want to have, well, I don't know, it depends on how you want to define it, but yeah, because I always, as you can see, my 0 indexes actually have a no element, and the reason why I have a no element is just that it makes certain math easier. But then here you just have to return prefix of right minus right plus 1 minus prefix of left. I think that's right. That would be embarrassing if it isn't. So let's hope so. Yeah, and you can kind of work out the index here from these formulas, knowing that you also add 1 for this thing here. So I guess in this case you don't really need it, but oh wait, what? Oh, whoops. Why is this a Why is this a string? That's odd. I just forgot something. That's all. I forgot to do it yourself. But I was wondering. I was expecting maybe a variable not found or something. But maybe that's a keyword somewhere. I don't know. Oh yeah. Whoops. Forgot that we're doing it with class, so that's why you have the self elements. But yeah, so this looks good. I am gonna add. I guess this already contains 0, but let's add a couple more test cases from here. At least the 2 things that I worry about, which is say 1 element, and then on both sides, and hopefully that should be good. So that looks good. So it's going to be enough for me to try to hit the submit. Hopefully that's good. Yep. Oh, so yeah. So the pre-processing here, you can see that this is linear because it looks at every element once, and here this is all of 1 because literally you're looking up an array which is all of 1 and then subtracting them. Overall, a pretty simple, straightforward problem for Monday. That said, there are 2 things, right? One is that the prefix sum comes up a lot for competitive for whatever reason, especially recently. So definitely get very good at this as much as you like. Take this opportunity to not, think about what every index means. And 2 is think about what every index means, because it's very easy to get it off by 1 if you don't really define precisely what your indexes are. And then you end up jiggling them to see if they're right or to get them right. But yeah, anyway, that's all I have for today. Stay good, stay healthy, have a good week. I will see you later. To good mental health. Bye bye.